1.17. If the peak in the mass spectrum of C2F6 at a mass number (138), the peak height is 100 units. Calculate the heights of the peaks at mass numbers 139 and 140. So this is also a probability question, right? So the mass number 138 comes when you have 2 carbons and there are 6 fluorine atoms, right? So 138 is possible when all the fluorine atoms have a mass of 19 AMU or 19 units, and both the carbon atoms have a mass of 12 units. That's (138). Now the probability of all the 6 fluorines having a mass of 19 units each is 100%, because 19F, the isotopic abundance of 19F is 100%. So this probability is always going to be 1. 1 times 1 times 1 times 1 times 1 times 1. Now the probability of a carbon atom having a mass of 12 is going to be, I'm gonna put an into symbol across so that it's not confused with the decimal points. It's going to be 0.9889, because 12C abundance is 98.89%. So the probability of having 12C is 0.988. And again, the probability of having another 12C is 0.9889. So the probability of the system having a mass of 138 units is going to be 0.9889 times 0.9889, which is 0.97792321. Now, for the system to have a mass of 139 units, the fluorines always have a mass of 19 units. So the probability is always going to be a 1 thing. There is no other way. And if you were to have 139 units instead of 138, it means one of the carbon atoms has a mass of 13 units and the other has a mass of 12 units. Now, we don't know which carbon has a mass of 13 units and which carbon has a mass of 12 units, right? So let's assume the first carbon has a mass of 13 units. Now the probability of that happening is 1.11% or 0.0111. And the second carbon has a mass of 12 units and the probability is 0.9889, right? So this is one scenario. And the other scenario is where all fluorines, as usual, have 19 units mass, and the first carbon has a mass of 12 units, and the second carbon has a mass of 13 units. Now, this is going to be 0.0111 times 0.9889 times 2. So the probability of this happening is this. Now, the only scenario where you can have 140 units is you have all 19F and both 13C carbons. So the probability of that happening for all fluorines is just 1. And both the carbons have 13 units. So the probability of that would be 0.0111, because that's the isotopic abundance of 13C, and 0.0111. Now this will give the probability of 0.00012321. Right? Now we have computed the probability of having a certain mass number. Now, when the mass number is 138 units, the probability is 0.977923321. And for probability of 0.977923321, the height is 100 units. For 139 units of mass, the probability of having that mass is 0.021953358. So the height is going to be, it's a simple unitary method, 100 divided by 0.9779231 times 0.021953358. So if 0.977, if a probability as high as almost 97% has a height of 100 units, a probability as low as only 2% is going to have a height of 100 divided by the 97% multiplied by 2%. It's a simple unitary method, and if we compute this value, 5358 divided by 0.9779233. This is going to give a height of 2.2449. So this is the height when you have a mass of 139 units. If you have a mass of 140 units, the probability is this, and the height is going to be 100 over 0.977923321 times 0.000123321. So the height of this is going to be 0.012321 divided by 97792. So the height of this is going to be 0.0126. So this is going to be the height.